All right, so welcome back. Today we're going to be going through some review in transportation planning for the transportation section as you're studying for your Civil FE exam. Now, this is the last section for the transportation section, so I want to go ahead and dive right in. Okay, so number one says, what is the RMEV? That's the crash rate per million entering vehicles at an intersection given the data. The number of crashes in a single year is 3, and the average daily traffic is 3,000 cars. Okay, so I always start by seeing what is given. Okay, so the number of crashes in a single year. Just highlight this stuff in green. This is good information for us. And the average daily traffic. Those are the two things that are given. All right. What are we trying to find? We're trying to find the crash rate per million, or the RMEV. And so are there any formulas needed for this? The answer to that is I don't know what RMEV is, and I'm just going to do a search because I think that will get me close. RMEV. All right. So now it's just a matter of looking at what they give us, right? It's at an intersection. I think that's important to note, because they give us a crash rate at intersections and they give us crash rates for roadway segments. So this is at an intersection. Okay, so the variables that we need is A and V. So do we have A? A is the number of crashes in a single year at the location. So we have A, which equals 3. Okay, information is given. This is why we write this stuff out. All right, so what is V? V is equal to, V is equal to ADT times 365. Do we have ADT? Because I don't know what V is, so I don't have V, but do we have ADT? Well, ADT is the average daily traffic entering the intersection. Average daily traffic that we have is 3,000 cars. So we do, in fact, have ADT. So now we can solve for V. Right. All right. So V is equal to 3,000 times 365. All right. So what does our V end up totaling to? So for V, we get 109.5 and 0.0.0. All right, so now we have V, we have A, and we can solve for our crash rate per million, our RMEV. So RMEV is equal to A times 1 million all over V, and we'll just substitute from there. 3 times 1 million all over V, which is 100, or not 100, but and for your RMEV, you should get 2.74. RA. All right, let's look at the next one. Number 2 says, what are the key parameters involved in a gravity model used for forecasting traffic flow between two regions in transportation engineering? What are the key parameters? All right, so the given information, not really applicable for this. Defined key parameters. Just gonna underline what we need in the gravity model. Forecasting traffic flow between two regions. So first place I would start is at the gravity model. So I'll just do a quick search. Okay. And from there, I'll look at my answer choices and say, okay, I'm looking for key parameters involved that are really going to affect or impact traffic flow between the regions, right? So the origin and destination elevations in this gravity model, the two regions that we're looking at, which is TIJ, and so what's happening, right? So what are the variables that are involved with this? So total number of trips produced, total number of trips attracted, friction factors, and economic adjustment factors. They're all what's contributing to this end result. So I don't see elevations involved, so I'm going to say no. Time zones of the origin and destination, no. Attractiveness of the road network, I think that's a piece of it. Populations of the origin and destination regions. I think definitely the destination and the origin is very important. The distance between the regions, I don't see that in this formula. The constant of proportionality, there are a few constants in this, including the socioeconomic adjustment factor and the friction factors of travel time between the zones. So distance between the regions is important. And then the attractiveness factors, right? So you want to know what's being attracted. So I'm going to say that D is the better answer here. If that makes sense. So more of those answers are directly affecting the number of trips that are produced in zone I and attracted to zone J. Right. All right. Let's look at number 3. Number 3 says, what is a key step in conducting a safety analysis for a stretch of highway with increased accidents? All right, so given information, not really applicable. What are we trying to find? We're trying to find a key step in conducting, we're looking at safety analysis for a particular stretch of highway with increased accidents. So what would really help us in our search to to get some more safety for an area that's really having issues with accidents. So historical weather patterns isn't necessarily going to analyze why there's an increased amount of accidents in a specific stretch of highway. So I would say no. Analyzing crash severity using GIS tools. GIS is based on location. I'm looking at like how severe these crashes are over a stretch of period. So I would say this is yes. Assessing traffic flow during non-peak hours. So I don't know if it makes sense to look at traffic flow, especially during when it's not busy. I would assume that less accidents will be taking place. So we're not focusing particularly on safety or particularly on accidents. So I'm going to say that's a no. And then implementing countermeasures without stakeholder input. So seems kind of more like a money move and is not analyzing anything. And it doesn't seem like the safety of the people is the most important here. So I'm going to say no. So your answer is going to be B. All right, this concludes the transportation engineering section. Next, we're going to be looking at construction engineering. So we're almost at the finish line.